Alright, this video will be a small review of scale factor and similarity. Let's start off with a little dilation. Graph the image after a dilation centered at the origin with the given scale factor. List the coordinates of the image. Okay, so you see that the scale factor is 0.5. Do you understand that 0.5 is the same thing as 1/2? Okay, so everything should be getting 1/2 as big. So these are the original coordinates of the vertices. We could get the new coordinates by multiplying each of these by 1/2. So these would be the coordinates of the new vertices after this dilation. So for example, I did -1, half of -1, and half of 3. So I mean, you shouldn't need a calculator for this, but if you did, you could take -1 times 0.5 like they gave us in the first place, or you could do 3 times 0.5. Okay, so that's where we got -0.5 and 1.5. So if you graph each of these new vertices, that will show you the dilation. So if I go -0.5 and 1.5, that's -1/2 a square and up a square and a half. So that would be right here. Okay, this will be my C prime. 1 and -0.5 would be over 1 and down 1/2 of a square. So there's my E prime. And -1, -1 would be right there. That would be my H prime. So that's what problem number 1 should look like. Okay, let's do the same thing for problem number 2. This time we have a scale factor of 2. Alright, here are the coordinates of the original points. Since the scale factor is 2, I can get the image under this dilation by multiplying all of these coordinates by 2. So these would be the coordinates of the image. So then we just plot them. Alright, and that is what it should look like for problem number 2. Alright, let's move on to number 3. What is the scale factor that turns ABC into XYZ? So see how this is getting smaller? So our scale factor should be something that is less than 1. So be careful about how you do it. So because the way they worded it, make sure you're getting something less than 1. Let's pick a pair of corresponding sides. I like to start with the biggest. Yeah, let's look at the hypotenuse. Alright, that's easy to do. So these are the two hypotenuses. So am I going to go 100 over 25 or 25 over 100? Well, we want the scale factor from ABC to XYZ. So we want to go big to small. So that means we need the scale factor to be less than 1. So you want to do this as 25 over 100 to make that happen. So the scale factor is going to be 1/4. Okay, not 4. Alright, for number 4 and number 5, we're supposed to determine whether the triangles can be proved similar. If they are similar, we're supposed to write a similarity statement and statement of proportionality. If they're not similar, we're supposed to explain why. Okay, so let's decide if these are similar. The way we will do that, and you have to show your work, is let's compare corresponding sides and see if they are proportional. So let's start with the biggest side. So the biggest side here is 7.5. The biggest side here is 5. So we match those up. The smallest side here is the 4.5. We've got the 3. And of course, that leaves the 6 and the 4. Okay, so these are lined up nicely, so it's not tricky. So let's just do those ratios and see if they are all the same. So let's see. Let's start with the green ones. All right, I'm going to do small over big. So if I do 5 over 7.5, I get that. Toggle it 2/3. Okay. The order doesn't matter. Let's do the blue ones next. Okay, so again, I'm going to do small over big. So if I do 4 over 6, that was a horrible 6, that reduces down to 2/3. Okay, we don't need a calculator for that one. So far, so good. Now let's do the pink ones. Alright, so if I do 3 over 4.5, alright, and again we get 2/3. Okay, so all the corresponding sides are proportional. So we will go ahead and write a similarity statement. By the way, I could have also asked you what theorem proves that these are similar, and we would have said the side similarity theorem proves that these are similar. Okay, but anyway, so the similarity statement, we will say that triangle MNP is similar to triangle QRS. Alright, that's the similarity statement. Now the statement of proportionality is going to be all of these, the ratios of all the sides. Not the numbers, but the letters. Okay, so for example, the pink ones, alright, so that's MN over QR. And the blue one, so NP over RS. And the green one, so MP over QS. Okay, so there's your similarity statement and your statement of proportionality. Okay, maybe I should put a box around that. Do we have enough information to know whether these are similar or not? We do, because we have one pair of angles that are given as congruent, but then we have another pair of angles that are vertical angles, and vertical angles are always congruent. So these will be similar because of the angle-angle similarity theorem. Okay, so fine, they are similar. So let's go ahead and write our similarity statement, which will be triangle NMJ is similar to triangle. Okay, now let's match them up correctly. Okay, the N goes with the K. Okay, the M, see the 65, goes with the L. Okay, and that leaves the J, which of course is the same for both. So there is your similarity statement. That's what's meant by similarity statement. Now the statement of proportionality when we do all the sides. So for example, NM okay, goes with LK. And that should equal MJ, and that goes with LJ. Okay, what's left? That leaves NJ, which goes with KJ. Alright, so this is your statement of proportionality. Alright, so for the next couple problems, we're finding the missing length. The triangles in each pair are similar. That's a given. Okay, so looking at these two triangles in number 6, it's all about picking two corresponding sides that we know. So for example, the 28 and the 42. Alright, that's a pair that we know. So let's go ahead and put those together as a fraction. So that would be 28 over 42. Okay, now we can set that equal to another fraction that's made out of, alright, the thing that we're trying to find and its corresponding side. So if I do 28 over 42, then I have to do question mark over 33. So it's just a matter of cross multiplying. Okay, so this will be, alright, 42, well, let me use x instead of question mark so it'll be more clear. Alright, so this will be 42x is equal to, let's see, 33 times 28. $924. Alright, if you divide both sides by 42, you get 22. Okay, so that was number 6. So how about number 7? Alright, same type of thing. Alright, we've got to be careful about what the corresponding sides are though. Okay, without a similarity statement, I think we have to go by the scale of the drawing. Which normally the drawings are not to scale, but I don't think we have a choice because we have to decide how these match up. So 21 is clearly the smaller side here, so I'm just going to have to go by the scale, and to me it looks like this is the shorter side between these two. So I'm going to match up, I'm going to call these corresponding sides. Alright, that makes these corresponding sides as well. So, I'm going to make my two fractions, green over green and pink over pink. So that will be 11x plus 11 over 30, and that should equal 77 over 21. Okay, so we just need to cross multiply. So be careful when you cross multiply with these. You're going to have to do the distributive property. Okay, in fact, let me set it up. So when I do 21 times 11x plus 11, that's like this: 21 times 11x plus 11. You're going to have to do the distributive property. 30 times 77, meanwhile, is 2,310. Okay, doing the distributive property, see, 21 times 11, 231. So that's going to give me 231x plus 231. Alright, if I subtract 231 from both sides, okay, so it's 2,310 minus 231, so that's 2,079. Excuse me. So that's going to be 231x. That made me forget what it was. 2,079. So now if I divide both sides by 231, nine. Alright guys, that's going to do it for this video. I hope it was helpful, and I will see you on the next video.